Welcome back to Statistics with Dr. Platt, episode 6. In this episode, we're going to start talking about our measures of most common value, or measures of center, as well as the measures of spread and position that go with them. So let us begin with the easiest one to find, which simply requires us to count the number of values that appear and how often they appear. This is our mode. Our modal value is a value that occurs the most. So going back to our football scores, we can see that a lot of numbers appear multiple times, but the number 20 appearing 5 times is more common than any other single value. So by counting, we can find that our mode is the number 20. This can also be computed using equals mode of the range of values that we're interested in discussing. In this case, they go from B14 over and down to E21. Since this formula has the apostrophe in front of it, it's not going to compute. But if we get rid of that, we do get the number 20, which is the mode of our data. So the mode is simply the most frequently occurring data value. Another fairly straightforward way to describe our data is our mid-range, which is associated also with the range of our value. The range is simply the distance between our maximum and minimum value. Where mid-range is the value which falls halfway between our maximum and minimum value. So to find our mid-range, we're going to take our maximum value, 44, our minimum value of 3, 44 plus 3, add them together, and divide by 2. To find the distance halfway between, you find the sum and divide by 2, and we already found our range, which will be equal to 44 minus 3. So the range of our values is 41 points. The mid-range is 23.5 points, which is an unachievable score, but it is the midpoint between the lowest and the highest. A far more common score is our mean, or arithmetic mean, or often just called our average. The mean comes in two varieties, depending on whether we're dealing with a sample or a population. If we're dealing with the entire population, then our population mean is computed by adding together all of our data values, then dividing by the size of the sample, or the size of the population, where our sample mean has us adding up all the values in our sample and dividing by the size of our sample. In this case, since we have all the scores for a given week, we want to find the total for that and the count of those. So to find our total equals sum of the values from B14 through E21. So we had 673 points scored. Our count equals count of B14 through E21. There are 32. If we find our average, we can do, or our mean more properly, equals G18 divided by G19. So we have 21.03, but we want to adjust this so that we have the proper one more decimal place than our answer. And we can figure this out using equals average of B14 through E21. And drop that in here. And it gives us the same value. Trimming it down to size. So that is our mean. However, knowing where the computed center of our values, or the total of all of our data values divided by our number of values, may or may not be as useful as one would think. The reason for that is that since we have we can have a single or two scores that are half of the team is going to score 20s and the other half score 22s, and we still get an average of 21.0. So one decimal place. Or the teams could have scored a whole bunch of 3s and a whole bunch of 44s, and they would end up not being 21, but it would have a widespread nonetheless. But what we want to use to figure this out is the average or the mean of the differences between our values and our mean squared divided by our number of elements. This is called our variance, where each of the differences between the mean and the data value is a deviation. And we can't just use the deviations the sum of the deviations divided by n, because that gives us an incorrect value, and it would be 0 anyway. So we have to use the squares. This can be computed by hand using the formula, the sum of the squares of the differences between x and mu, our population mean, where x is our data value, all divided by n. And the square root of that is called our population standard deviation. Or we can use our computer to give us a hand. Okay. Variation.p gives us our population variance. And we highlight all of our data. And we get a value of 76.4. And this is the square of our differences. To find a more useful number that would not be in points squared per game, but rather points per game, or just points, we can find our standard deviation, which is equal to ST DEV dot, since we have all of our scores, we're going to use dot P, and we choose all of our values, and we get 8.7. As our standard deviation. So what our standard deviation tells us is how widely spread our mean values are. And there is a relationship that about 68% of our data is within one standard deviation of our mean, which means more than 2/3. Within 2 standard deviations above and below our mean, we have approximately 98 or 95% of our data. And in a large sample that is symmetrically distributed with a nice bell shape called a normal distribution, about 99.7% of the data falls between -3 standard deviations, which is on the left of our mean, and +3 standard deviations, which is to the right of our mean. If we want to find the standard deviation for a sample, it is done relatively similarly, except that it was found that using just the sample size gave an overly large approximation of the standard deviation. Underestimated it, so they needed to make the denominator a little bit smaller. So our sample variance, S squared, is the sum of x minus x bar, the data value minus the sample mean, squared over n minus 1, with our sample standard deviation being S, which is the square root of the sum of x minus x bar squared over n minus 1. And this can be found using equals ST dot S of, let's go with the left 3 columns of our data. Let's use a slightly more representative sample. We're going to use the top 6 rows of our data, and it gives us a sample standard deviation of 8.1. Since we have a slightly different set of data, let's find the sample mean equals average of the top 6 rows. So our average is a little bit lower than our population mean, with our sample being a little bit narrower as well. So see you on the next slide for the next distribution or way to describe data.